Hey everyone, and welcome. Have you ever said the words, well, it works on my machine? Of course you have. We all have. Well, today we're going to talk about the tool that makes that phrase a thing of the past. We're going to see how Docker takes your code and turns it into an application that runs anywhere, every time. So, how does it work? It's really just a simple three-step process. First, we write a blueprint, which is called a Docker file. Then we use that blueprint to build a self-contained package called an image. And finally, we press play and run that package as a living, breathing application called a container. That's the whole journey right there. And here's our game plan for the next few minutes. We'll start with the why, the big problem Docker solves. Then we'll get into the how, writing the Docker file, building the image, and running the container. And then the really crucial part. How do we actually connect to our app once it's running? All right, first things first. Let's talk about that core problem. As developers, we've all been there. You build something amazing on your laptop. It works perfectly. You give it to a colleague, and it just explodes. Why? Because their machine is different from yours. Different libraries, different versions, you name it. This is the key. Docker provides a standardized, consistent environment. It's a platform that lets you take your application and literally package it up with all its dependencies, every little thing it needs to run, into one tidy, isolated box. This means it's going to run the exact same way no matter where you put it. So, how do we start building this box? Well, it all begins with a single text file, a very special file called the Docker file. This is ground zero. You know, the best way to think about a Docker file is like a recipe for a cake. You can't just tell someone to bake a cake. You have to give them step-by-step instructions. Start with this much flour, add this OS, copy in my code. And when you're done, run this specific command to start the server. It's a list of instructions top to bottom. Okay, so we've written our recipe. Now it's time for the fun part. We get to actually do the baking. We're going to turn that text file, that recipe, into something real and portable. And this one little command is what kicks the whole thing off. It might look a bit like magic, but it's really simple. Let's break down exactly what we're telling Docker to do here. First up, Docker build. This is the action, the verb. It's us saying, hey Docker, wake up. I've got a recipe here and I need you to build something for me. Pretty straightforward, right? Now, this next part, T my app, is super important. The T stands for tag, which is just a fancy word for giving our creation a name. If you skip this, Docker will just spit out a long random string of numbers and letters that you'll never remember. By tagging it my app, we can easily find and use it later. Trust me, always tag your images. And what's the deal with that lonely little dot at the end? It's just telling Docker where to find the recipe and all the ingredients. The dot simply means look for the Docker file right here in the current directory. So after we run that command, what do we get? We get a Docker image. This is our finished cake. It's a perfectly sealed read-only package that has everything inside it. Our code, the runtime, all the tools and settings. It's a perfect snapshot that will work the same way no matter where you send it. We've got our packaged meal, our image. It's just sitting there, waiting. Now it's time to actually serve it up and bring it to life as a real running application. And here's the command that does it. Docker run is what we use to start a new container from our my app image, but pay close attention to that -p part. That is the secret sauce that actually lets us interact with our app. Now let's be super clear on the difference here because it trips everyone up at first. The image is the blueprint. The container is the actual house built from that blueprint. It's the live running instance. You can have one single image and use it to launch 10 or 100 identical containers. Okay, let's zoom in on that P flag because this is probably the biggest aha moment for anyone starting with Docker. By default, a container is a completely sealed off box. That P flag is what builds a bridge to the outside world. Think about it. Your app is running. Everything looks good in the logs, but it's inside this isolated box. So how in the world do you actually connect to it from your web browser? If you just go to your browser now, you'll see nothing. And this quote just nails it. The app is running, but you haven't shared its communication channel, its port, with your computer, the host. We need to create a tunnel, a mapping, from the outside in. And here's what port mapping does. It creates a direct link. When you type localhost 3000 into your browser, you're knocking on port 3000 on your computer. The port mapping then forwards that traffic directly through the tunnel to port 3000 inside the container, where your app is waiting to answer. So that P3000 command literally means map my computer's port 3000 to the container's port 3000. The number on the left is the outside world, the host. The number on the right is the inside world, the container. And just like that, you've opened a door. So let's recap the whole thing one more time. You start with a Docker file. That's your recipe. You use Docker build to create a portable image. That's your packaged meal. You use Docker run to launch a live container. That's you serving the meal. And you use the -p flag to open the door so people can actually get to it. So this is fantastic, right? This process is an absolute game changer for getting one application running reliably. But it immediately brings up the next big question. What happens when you need to manage not just one container, but dozens or even hundreds, all working together? Well,